Hello everyone, in this video we are going to learn about the similarity theorems. At the end of this lesson, you should be able to, number one, illustrate and state the similarity theorems. We are going to talk about the four: AAA, similarity, AA corollary, SAS, and SSS. And we are going to solve problems using these similarity theorems. So if you can recall the definition of similar triangles, two triangles are similar if and only if we met the following conditions. Number one, all three pairs of corresponding angles are congruent, and all three pairs of corresponding sides should be proportional. The question is there a simpler way of knowing if two triangles are similar? So to answer that, we will use the following theorems to prove triangle similarities. So let's start with the first. We have the AAA similarity theorem. So we have here a correspondence between two triangles. We have here triangle ABC, which corresponds to triangle DEF. So if the corresponding angles are congruent, then the correspondence is a similarity. Ang ibig sabihin nito, angle A should be congruent to angle D, angle B should be congruent to angle E, and angle C should be congruent to angle F. So if we meet these three congruent corresponding angles, then by AAA, the two triangles should be similar. Triangle ABC is similar to triangle DEF. For the next one, we have the AA corollary. It states that if two pairs of corresponding angles are congruent, then the correspondence is a similarity. So in other words, if we have triangle ABC, which corresponds to triangle DEF, if we can show two pairs of corresponding angles that are congruent, then we can already conclude that the two triangles are similar. So if we can show that angle A is congruent to angle D and angle B is congruent to angle E, so automatically by the AA corollary, the two triangles, triangle ABC is similar to triangle DEF. So it is a simplified version of the AAA similarity theorem. For the next one, we have the SAS similarity theorem. If two pairs of corresponding sides are proportional, so take note, two pairs of corresponding sides should be proportional, and then the included angles are congruent. So by the SAS similarity theorem, the two triangles are similar. So again, we have here the correspondence between ABC and DEF. So here, if we can show that AB over DE, the proportion of the two pairs, BC also and EF, so if they are equal and their included angle, so for triangle ABC, we have here side AB and side BC, so their included angle is angle B. And similarly for the smaller triangle, we have side DE and side EF, their included angle is angle E. So if we can also show that angle B is congruent to angle E, then by the SAS similarity theorem, the two triangles, triangle ABC and triangle DEF, are similar. And lastly, we have the SSS similarity theorem. This is the opposite of the first theorem, AAA. So here we need to show that the corresponding sides are proportional, so that we can say that the two triangles are indeed similar. So if we are given the same correspondence between ABC and DEF, then if we can show that the proportions AB over DE equals BC over EF, and it is also equal to AC over DF, then we can say that the two triangles are similar. So let's look at some practice problems. Given the following pairs of triangles, determine if they are similar or not. So if they are similar, let us try to see what theorem was used to justify the answer. So for number 1, we have here triangle ABC and triangle FGH. So if we notice, angle C is congruent to angle H because they are both 52 degrees. However, we cannot say that angle B is congruent to angle F because angle B is 81 and angle F is 47. But if we solve the missing angle of this triangle, since we know that the sum should be equal to 180, so 180 minus the other two given angles, that gives us 47 for angle A. And similarly for angle G, this will give us a value of 81 degrees. So if we look at our given pair, angle A is now equal to angle F. They are both 47 degrees. And then angle B is now congruent to angle G because they are both 81 degrees. So we have here three pairs of congruent corresponding angles. Therefore, by AAA similarity, we can say that triangle ABC is similar to triangle FCFH, or sorry, this should be triangle FGH. Okay, so by AAA similarity. And then for number 2, there are no labels here, but we can say that this triangle T1 and this triangle T2, they are both right triangles because of this indicator. So this is 90-degree angle. This is also 90-degree angle. Aside from that, we also know that this side of T1 is congruent to this side of T2. And there are no more information available for us to decide. So for number 2, since there are no enough information, kulang, we can say that the two triangles are not similar. No enough information. Next, for number 3, given two triangles, this is your T1 and this will be our T2. Given all the measurements of their sides, so let's see if we can form a proportion out of those pairs. So let's start with the longest sides for T1 and T2, so that those are 17 over 13. For the shortest side, that is 8 for T1 over 5 for T2. So if we look at the proportion, they are not equal. Okay? So if you want to check also for the second longest side, then we can also say that 15 over 12 is not also equal to the other two proportions. So therefore, not similar. For number 4, T1 is this larger triangle, this one. And T2 is this smaller triangle. And since we are given here T1 is an isosceles triangle because the two sides are equal in length. Also with T2, the two sides are equal in length. And if we look at the correspondence between T1 and T2, we can form the proportion of their sides. So 7/3 for the leg, one leg, and another 7/3 for the other leg. So there is a proportion of the corresponding sides. And since we have here a pair of vertical angles, we can say that angle A and angle B are also congruent. So angle A is congruent to angle B, and those two angles are included angles. Therefore, by SAS similarity theorem, we can say that T1 is similar to T2. And lastly, for number 5, so no labels again. Let's label them as T1 and T2. Here we know that T1 has one angle which is equal to 56, and another for T2 which is also equal to 56. So if we label this as ABC, and then for T2, let's label it as CDE. Okay, so angle A is congruent to angle D. Okay, so if we look at T1 and T2 correspondence, and for the pair of vertical angles, which is this one and this one, we can say that for T1, angle BCA is congruent to T2's angle DCE because they are vertical angles. So what do we know here? So there are two pairs of congruent angles for the two triangles. Therefore, by the AA corollary, we can say that T1 is similar to T2. Okay, so let's look at other types of problems that we may encounter later on in our assessments. Suppose we have here two triangles, triangle CON and triangle VEX. The question is, which similarity theorem will justify that these two triangles are similar with the given conditions? So for letter A, we are given with angle C is congruent to angle V. And then we have CN, which is 6, VX, which is 9, CO, which is 8, and VE, which is 12. So kung talagang similar ang triangle CON at triangle VEX, so dapat merong proportion ang kanilang corresponding sides. So if we do the correspondence, CON corresponds to VEX, we can say that CN over Vx should be equal to CO over Ve. So substituting the values, 6/9, is it equal to 8/12? Are these two ratios equal? So the answer is yes. So they are indeed equal. So we have proven that the corresponding pair of sides are proportional, which are these sides, and then angle C and angle V are the included angles. So therefore, ang ginamit natin sa letter A ay SAS, similarity. Okay? And then for number 2, all the sides are given. So this time, CO is 6, CN is 4, and ON is 8. And for the other triangle, VE is 9, VX is 6, and EX is 12. So since given lahat ng sides, most probably ito ay SSS. But let's try to verify kung pwede ba talaga si SSS, no? So again, considering the correspondent CON and VEX, so dapat CN over VX is equal to CO over VE, and that should be equal also to ON over EX. So let's see the values. That is 4 over 6. Is it equal to 6 over 9? Yes, 36 equals 36 if we cross multiply. And is it equal also to 8 over 12? Yes, no? So if we simplify these three ratios, the lowest term is a fraction equivalent to 2/3. So yes, by SSS similarity theorem, the two triangles should be similar. Another example, given triangle ABC and triangle DBE, find EB given that AC is 8 and then DE is 6 and then CB is equal also to 6. So paano kaya natin to isolve? So triangle ABC, then triangle DBE. So first and foremost, are these two triangles similar? So since in the figure DE is parallel to AC, then we can say that angle BDE is congruent to angle BAC. So they are both consecutive angles, and since we have here two parallel lines crossed by a transversal line, then consecutive angles should be congruent. And then for the two triangles, pareho silang merong angle B. So angle B is congruent to angle B by reflexive property. Therefore, we can say that by AA corollary, the two triangles ABC and DBE are similar. Okay? So since similar triangles sila, the corresponding pairs of sides should be proportional. So tignan natin ano yung mga proportion na mafo-form natin for item A. So find EB, so this is unknown. AC is 8, so this is 8. DE is 6. CB is 6. So this whole right here. Okay? So by the proportion of corresponding sides for ABC, triangle ABC, we can say that DE over AC, okay, is equal to BE over BC. So ang ginawa ko dito, the ratio of the smaller triangle all over the bigger triangle. So this is 6 over 8 is equal to BE na unknown and BC or CB na 6. Okay, so you can solve this easily using our technique, which is cross multiplication. So BE is equal to 36 all over 8. So divided by 4 divided by 4. So BE in fraction form is equal to 9 over 2 or 4.5. So that's how you solve for the missing parts of triangles. So you need to establish first the similarity between two pairs of triangle. Then using our definition, you can get the proportion of the corresponding sides, or you can get the congruence of corresponding angles. So this ends our topic for the similarity theorems.